Kia ora Year 12, here's the second video from yesterday's test. So in this video I'm going to try and get through the differential equation question about the leaky tank and then the kinematics question that was the first one on the sheet. So looking at the DE question first, remember we always need to carefully set the problem up correctly or we're going to waste a whole lot of time. So in here, reading it carefully, the tank holds 2,500 litres of water and it gets a hole in the base. The water leaks out at a rate proportional to the square root of the volume of water left in the tank at any instant. So that's the key bit for the setup, right? So dV by dt, V is the volume of water, is equal to negative K root V. I don't have to make K negative. If I just leave it as K, I should come out with a negative number, but it's just, I find it easier to make it a negative number if I know that it's decreasing or leaking. And we've got a couple of points on the curve. At t equals 0, the volume is 2,500. And then 2 days after the leak started, 475 litres have leaked out of the tank. Be really careful with that. That means that we've got 2,500 minus 475, which is 2,025 litres after 2 days. So the second point that we're going to use is this one here. So you should have a feel by now that we're going to end up with two constants of integration, two constants. The first constant is this one, and the next one will be the plus c that I get. The first step we've got to do is to find a general solution, and we do that by separating the variables. So I'm going to have 1 over root v dv is equal to negative k dt. Integrating both sides gives me this. So here I'm going to rewrite that as v to the negative half dv, and over here I'm going to have negative kt plus c. So I've done that as a fractional power to avoid making mistakes. So over here we're going to get v to the power of a half times 2 is equal to negative kt plus c. Just let's look at what we're being asked to find. We have to figure out how long it will take the tank to empty out completely. So at this point I can substitute in my first point here and get one of the constants worked out. So 2 root 2,500 is equal to 0 plus c. That gives me 2 times 50 is equal to 0 plus c. C is equal to 100. Putting that back, we get 2 root v is equal to negative kt plus 100. And now I can substitute my next point, this one here. And that will get me a full solution to the equation. So we get 2 root 2025 is equal to negative 2k plus 100. Now just be careful there. It's quite a common mistake to substitute that 2 and to accidentally replace the k, but 2 is the value of t. Okay, so 2 times 45, which is what that is, gives us 90. 90 equals negative 2k plus 100. Rearranging carefully, I get negative 10 is equal to negative 2k. K is equal to 5. Finally, we've got our equation. 2 root v is equal to negative 5t plus 100. Okay, so that's where we've got to. The next question, the final question, is to say how long does it take the tank to empty completely? So that's now a very, very simple problem. We want v equals 0, and we'll just write down empty tank. So 0 equals negative 5t plus 100. That gives us 5t equals 100. T equals 20 days. And then, because we're doing NCA, 20 days to empty the tank. So there you go, that's the first one done. The second question is a kinematics one. And it really could be a level 2 question, except that we are integrating an exponential function, but otherwise it's not too hard. What you have to remember is that we've got 3 things in kinematics. We've got displacement, velocity, and acceleration, and to get from one to the other we differentiate and we integrate to go backwards. So here we're given v of t is equal to 20 minus 15e to the negative 0.2t, blah blah blah, and we're asked what distance did the object move in the first 10 seconds of its timed motion. And we need to give the results. We need to use integration to do this. Okay, So displacement in this case is going to come from the integral of the velocity function. And we're looking for a definite integral because we want to know how far it went in the first 10 seconds. So that's between 0, when it started being timed, and 10. That gives us the following thing to work out. So 20t, then we're going to have e to the negative 0.2t here. We want to end up with 15, but when we do the chain rule to differentiate, we're going to have negative 0.2, so it's going to be this. So we're going to clean that up before we do anything else. So we're working out this 20t plus, so 15 divided by 0.2 is 75, so 75e to the negative 0.2t at those limits. Substituting in now, we get 200 plus 75e to the negative 2 minus 0 plus 75 times 1. Now this is one of those times when we're integrating where a common mistake that students make is to see that that's a 0 and to think, oh yeah, all of that term is going to be 0. So it's often not. And the two times where it's most often not are going to be where we've got an exponential or where we've got a cosine function, because cosine of 0 is 1. So just be careful to watch out for that. Now if you grab your calculator and work all of that out, you'll get 125 plus 75 times e to the negative 2, and that gives me all up 135.15 meters, and that's to 2 dp. Okay, so that's those two questions done, and I'll do the last two shortly. Let's just go back to the start. Nope, that's the wrong video. Okay, the start of that question's there. Thanks for watching.